So I just have some seismograms drawn here that was actually taken from a seismograph station. And we'll look at this particular one right here first. And all I can tell from this seismogram is that the earthquake is very close by, because the P wave arrives and the S wave arrives only 4 minutes after. So that's a very small interval of time between the arrival of the first P and the first S, keeping in mind that a P wave travels at 6 kilometers per second and an S wave travels at 3.5 kilometers per second. As you can see in this particular seismogram, this is a case where the earthquake, the station is much further away from the earthquake, because the arrival of P and S has a 25-minute interval in between. So we know that this station is far from the earthquake epicenter, whereas this one here was closer to the earthquake's epicenter. Next, we're going to talk about size, big or small. So in this particular case, we're looking at a seismogram of an earthquake that's small. For size of an earthquake, we obviously go to the S wave and we look at the amount of amplitude. Now, amplitude is measured from the baseline to the crest, or from the baseline to the trough. So as you can see in this particular example, there's not much amplitude on the S wave, so we say that the earthquake is small. In this particular one here, when we look at the S wave, we can see that there's way more amplitude on that S wave, so we know that the earthquake is much bigger. The other thing that I wanted to talk about was magnitude. You often hear about the magnitudes of earthquakes on TV or in the news, and if a magnitude is 1 higher or 2 higher, what does that mean? So I just have one example here. We have an earthquake A with a magnitude of 5.2 and an earthquake C of 6.2. So basically, there is only one difference of magnitude between 5.2 and 6.2. That's still a big deal. An earthquake that is a 6.2 has 30 times more energy released than an earthquake that's 5.2. If you had an earthquake that was 5.2 and an earthquake that was 7.2, well, there's 30 times more energy between a 5.2 and a 6.2, and there's 30 times more energy between a 6.2 and a 7.2, so 30 times 30 is 900 times. So what that means is there's 900 times more energy in an earthquake 7.2 than an earthquake 5.2. Now, if you're not talking about energy released, magnitude, and instead you're just talking about amplitude on an S wave, well then for those same earthquakes, there would be 10 times more amplitude on an S wave for an earthquake of 6.2 than an earthquake of 5.2. Between a 5.2 and a 7.2, well, there's 10 times more amplitude between a 5.2 and a 6.2, and there's 10 times more amplitude between a 6.2 and a 7.2. 10 times 10 is 100. So there's 100 times more amplitude on the S wave of a 7.2 earthquake than a 5.2 earthquake. So that's how those numbers work. The most important thing you need to keep in mind is, are you using 30 times or 10 times in questions on the public exam or on an assessment in class?